Okay, so far we've talked about parts of graphs. We've talked about how to calculate the vertex algebraically. And now we're going to talk about graphing. But before we graph, we're going to really take a close look at some graphs. So that way we can figure out what the relationship is to the graphs and what we're trying to do. So here we have the equation y equals x squared. Oops, want to be in pen mode. So y equals x squared. And so as we look at our graph, here's our vertex, which is at 0, 0. And then instead of slope, because remember, lines have a true slope. So if it's slope of 1/2, we go up 1, right 2, up 1, right 2. Well, with our quadratics and our parabolas, our slope is a little different. It changes, and that's how we get the curve. So on this one, I'm going to go up 1, right 1, and up 1, left 1. So I go up 1, over 1. And I'm going over in both directions. Now from here, we're going to go up 1, 2, 3 over 1, up 1, 2, 3 over 1. So then we go up 3 over 1. And then we're going to go up 1, 2, 3, 4, 5 over 1, 1, 2, 3, 4, 5 over 1. So now we're starting to see a pattern. 1, 3, 5. And some people would say they're prime numbers, but they're not really because 1's not prime, but they're odd numbers. So you can bet if we looked at a bigger graph, it would now go 7 over 1, so on and so forth. So now let's look at our next one. Y equals x squared minus 9. So now let's look at our vertex. Our vertex is down here. So x value is 0, y value of negative 9. And our slope is up 1 over 1. And then up 3 over 1. And then up 1, 2, 3, 4, 5 over 1. And then up 1, 2, 3, 4, 5, 6, 7 over 1. And so we're seeing that even though it's centered at a different spot, we still have that same slope, or as I like to call this, it's a pattern of change. Because slope indicates that it's the same all the time, and it's really not the same all the time. And so we call that pattern of change just to distinguish that there is a difference there. So now we're going to move to the next one. And it looks like our vertex is over, let's see, so x value of 1, y value of 0. And our slope is up 1 over 1, up 3 over 1, and then up 1, 2, 3, 4, 5 over 1. So I'm starting to see a pattern, and I'm starting to think all parabolas have a slope of up 1 over 1, up 3 over 1, up 5 over 1, up 7 over 1. And so far, everything looks like that. But I also want you to pay attention to this. Nothing's changed with that. And nothing's changed with our slope. So maybe if we get something different there, something will happen. So now let's look at these problems. So now we have y equals 2x squared. So now let's go ahead. Our vertex is at 0, 0. Our slope, up 2 over 1. Up 1, 2, 3, 4, 5, 6, 7. What? 1, 2, 3, 4, 5, 6, 6. I don't know what I was thinking of 7. And then we're out. So that's kind of weird. So now let's look at our next one. Again, we have a 2x squared there. Our vertex this time is at negative 1, 0. And our slope is up 2 over 1. Up 1, 2, 3, 4, 5, 6 over 1. Okay, so it looks like I have that again. So it's a little different. So now let's look at, there's a 3 in front. So let's see, our vertex now is at 0, -9. And let's look at this slope. So up 1, 2, 3 over 1. Up 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. And then it looks like we run out of room. So now let's look at over here. Again, we have a 3 in front. So let's see, where's our vertex? 2, -5. And we go up 1, 2, 3 over 1. We go up 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. So now I want you to think about what's really happening here. We started off with 1, 3, 5, 7 when there was a 1 in front. When there's a 2 in the front, we had 2, 6, and I bet you it would be 10, and then 14. And then when we had a 3 in the front, we had 3 and 9, and then I bet you it would have been 15 and 21. How did we get these numbers? I take that number that's in front and I times by the original slope. So that number in front helps dictate what the slope or the pattern of change is for our parabolas. So instead of creating a table to graph a parabola, we can use those patterns for that slope or rise over run, and the parabola slope changes in a pattern called pattern of change, which looks like 1a, 3a, 5a, 7a. And remember, a is that number in front of x squared. And we can use that to find the remaining points on the graph after we have found the vertex. So the pattern of change for any quadratic function should always be 1a, 3a, 5a, 7a. So on and so forth. So as we look at our problem, graph y equals x squared minus 4x minus 5, we start with finding our vertex. So x equals negative b over 2a. So negative b over 2a. Remember, if there's no number in front, there's really 1 there. So this becomes positive 4 over 2, which gives me an x value of 2. Then we're going to plug in to find our y. So let's see, 2 squared minus 4 times 2 minus 5. So y equals 4 minus 8 minus 5. So y equals negative 4 minus 5. And y is negative 9. So my vertex is at 2, negative 9. And then my pattern, because there's a 1 in front, is just going to be 1 times 1, 3 times 1, 5 times 1, 7 times 1. So up 1 over 1, up 3 over 1, up 5 over 1, and up 7 over 1. So when we graph, we're going to go to 2, negative 9. So there's my vertex. And now from here, I'm going to go up 1 over 1 in both directions. And then up 3, 1, 2, 3 over 1 in both directions. And then up 5, 1, 2, 3, 4, 5 over 1 in both directions. And then up 7, 1, 2, 3, 4, 5, 6, 7 over 1. And there is our graph. So now we're going to keep practicing. So next one, let's go ahead and find our vertex. X equals negative b over 2a. Whew, I forgot to change this one. So this becomes negative 6 over 4, which is negative 1.5. And yes, this happens, so be really careful about it. You won't see this a lot in our assignments, and I thought I meant to change this, but I must have forgotten to. So negative 1.5 And then we would plug that in. So y equals 2 times 1.5 squared plus 6 times 1.5 plus 2. Then we're going to grab our handy dandy calculator and use that to help us figure this out. Usually we don't get these types of problems till we're in Algebra 2. So this becomes 2.25 and then I times by 2. So y is 4.5 and then 6 times 1.5 is 9 and then plus 2. It doesn't even fit on my graph. 4.5 plus 9 plus 2 gives us 15.5. So we do have a vertex, negative 1.5 and 15.5. But we can't graph on this graph. So we're going to move on. Which is fine because I think I have plenty of problems for us to practice. Yeah, we're good. So our next one, x equals negative b over 2 times a. So now we get negative 6 over negative 2, which is positive 3. Now that we have the positive 3, we're going to plug that back in. So y equals negative 3 squared plus 6 times 3 minus 9. So we get y equals negative 9, because the negative's on the outside, plus 18 minus 9. So y is 9 minus 9, which is 0. So we have a vertex of 3, 0. There we go, much easier. And then our pattern is going to be based on that a in front. So 1 times a, 3 times a, 5 times a. So we're going to go negative 1, so down 1 over 1 in both directions. Down 3, 1, 2, 3 over 1 in both directions. And then down 5 over 1 in both directions. And there is our graph. So 2 more examples, and then you guys are good to go for the night. So we're going to go back and we're going to figure out x equals negative b over 2a. So now we have a negative 6 over 6, which becomes negative 1. So for my vertex, we're going to start at negative 1, and then we plug it in to find our y. So y equals 3 times negative 1 squared plus 6 times negative 1 minus 1. So y equals, let's see, negative 1 times negative 1 is 1. So 3 times 1 is 3. Minus 6 minus 1. So now we get negative 3 minus 1, which is negative 4. So now my vertex is at negative 1, negative 4. And then we use our slope. So if our number in front is 3, we're going to do 1 times 3, 3 times 3, 5 times 3, 7 times 3. So we're going to go up 3, 1, 2, 3 over 1. Then up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1. And it looks like we run out of room. So there's our graph. Okay, last one. Woohoo! Okay, so start off with our vertex. X equals negative b over 2a. So negative 8 over negative 4, which gives us positive 2. So our vertex will be at positive 2 something. And then we're going to go ahead and plug in. So I'm going to do that down here where I have a little bit more room. So y equals negative 2 times 2 squared plus 8 times 2 minus 6. 2 squared is 4. Negative 2 times 4 is negative 8. 8 times 2 is 16 minus 6. So we get 8 minus 6, which gives us 2. So our vertex is at 2, 2. Now our slope should be 1 times a, so 1 times negative 2. 3 times a, 5 times a, And since it's negative, that means we're going down. So down 2 over 1, both directions. Down 6, 1, 2, 3, 4, 5, 6 over 1 in both directions. And there is our graph. So have fun graphing, and we'll see you next time.